afternoon. Welcome to Sriveda IT. This is DS Prasad, an AI engineer. And the next concept, so that is sixth concept from the recursion that we are going to learn today. So why do we need recursion, which is a more important concept. So from now onwards, every concept is very much important. Okay. So why do we need recursion means so many problems. So there are so many problems are there are naturally so divided into smaller versions. Smaller versions. What is the meaning of it means? So with the help of recursion, many problems are naturally divided into the smaller versions. That is one case. So instead of writing long loops, long loops, recursion makes them so makes the programs easier. So with the help of recursion, we can make the program very simple and easy to write instead of writing the long loops. For example, so any case that we can take means example factorial is there. So what is the base condition for the factorial? So there are two different base conditions will be there. So sometimes three, sometimes one, sometimes two, like that we are going to get it. If n less than zero, so n less than zero in the sense means negative number. For negative number, there is no, so written nothing, no factorial. Otherwise, if n is equals to 0 or n is equals to 1, then so what we have to take means, so we have to take, so return 1. Sir, why I am taking n is equals to 0 or 1? See that we have to decide it. So which one is the best? So n less than 0. Okay, this is condition. Okay. Is n equals to 0 or n is equals to 1? Both of them I have to consider are not required. This one. So why only n equals to 1 required? Because if you take 5 factorial, you see that we know 0 factorial is equals to 1 and 1 factorial is equals to 1. If I multiplied 1 multiplied by 1, 1 only. So is there any usage of this 0 factorial? No. So that's why I'm going to stop at n is equals to 1, return 1. So return 1. 5 factorial means 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1 only. When 1 reaches, just return 1 only in place of that. So 1 factorial. So that's it only. So here 5 fours and 3 times and then this one will give around 120 is the output. Okay. So n is equals to 0 is not required. But here still we are taking because of for explanation purpose only. Okay. So how to use the recursion call? So recursion call or recursive call. So how to use the recursive call for the 5 factorial? So here how the 5 factorial will come? So here for the 5 factorial. So now you see that 5 multiplied by 4 and I'm going to take the 4 factorial. Here 4 factorial is nothing but called as small problem. So which is nothing but small problem. So we call it as a small problem. And after that, so here again, so 5 multiplied by 4 multiplied by 3 factorial. So 3 factorial is a smaller problem. So what is the duty of recursion is to solve the smaller problems. Again, so here after that, so 5 multiplied by 4 multiplied by 3 multiplied by 2. So which is nothing but another smaller problem. So 2 factorial, which is nothing but a so smaller problem. So smaller problem. And again, so here, so 5 multiplied by 4, so multiplied by 3, multiplied by 2, multiplied by whenever it reaches the 1. So when n value is equals to 1, we are saying that return 1 only. So 1. So this is nothing but called as, so here problem is solved, which is nothing but a base case. So output will be solved and we are going to get that output as so 120. So output as 120. This is one kind of example. So can I take another example? Means yes, we can take another example. So that is sum of n natural numbers. Natural numbers. We know that natural numbers always starts from so 1 only. Starts from 1. Okay. Okay. So here f of n, if I take the function f of n is equals to so 1 plus 2 plus 3 plus 4 plus so on plus n. So n is the number that we are going to take. Okay. So here, what are the different base cases? So base conditions are base cases that are available. So just think of it. So here again, when we are getting the one, we are stopping it. So here f n is equals to 1. So what is our duty means we have to return 1 only. Okay. Otherwise, so if n greater than 1, we are going to start from n greater than 1, or so we are going to take or so is n less than 0. So n less than or equals to 0. So here equals to 0. So what will happen? So we need to think of about the programming like that. Like different base cases will come. So how to write that one? For example, I want to find the sum of the natural number 1 only. So the output is 1. And I want to solve that sum of first two natural numbers is nothing but 2. After that plus next again I'm going to take the smaller function which is nothing but 2 minus 1 because see sum of natural numbers. For example, only n is equals to 1 is there. What is the output? 1 is the only one. N is equals to 2 means, so 2 plus 1, which is nothing but 3 is the sum. Okay. Where n is equals to 3 means first three natural numbers sum. So 2 plus 3 plus 2 plus 1, which is nothing but 6. Okay. Like that. N is equals to 5 means, so 5 plus 4 plus 3 plus 2 plus 1, which is nothing but 15. So this is the case where we are going to see. Okay. And how I am going to get this the next number means, so for example, this is n. This is getting n minus 1. Okay. And if I take this as a recursion function, I am going to take n plus f of n minus 1. Okay. So here, this is nothing but n. So here, let's take that n is equals to 2 means 2 plus f of 1. Whenever is n equals to 1, we are going to say that return 1 only. So that 2 plus 1 will get 3. Otherwise, if you take n is equals to 3, now you can see that 3 plus f of 2. Again, f of 2 means, so f of 2 plus f of 1. Again, f of 1 means 1 only. So 1 plus 2 is nothing but 3. 3 plus 3 is nothing but 6. This is the output. So similarly for n is equals to 5. 5 plus f of 4. So f of 4 means, so again 4 plus f of 3. The function calling itself. And 3 means 3 plus f of 2. Again, f of 2 means 2 plus f of 1. Whenever it reaches the base condition, it returns that value 1. So 1 plus 2 is nothing but 3. 3 plus 3 is nothing but 6. 6 plus 4 is nothing but 10. So 10 plus 5 is nothing but 15. This is the output that we are going to get. Okay. So that is the importance of this base case. So here, so this is nothing but a smaller problem. So this is nothing but a smaller so problem. Okay. So similarly, if you take f of 3, so f of 3 if you take, so only 3 plus, so f of 2. 2 will take the remaining cases. Here f of 2 is the so smaller version, smaller problem, version or problem, whatever it means. Okay. For example, if you take f of 100, so what is the smaller problem for this 100 plus f of 99, which is the smaller problem. So here every problem depends on the smaller problem. This is a problem and depends upon the smaller problem. Here, so f of n overall equation for the sum of first n natural numbers means n plus function of and then n minus 1 change in the parameter leads to the base condition. Whenever if you write the base condition, automatically, so it will stop the recursion. Okay. So this is nothing but called as what is the need of recursion. Many problems are naturally divided into the smaller versions. Instead of writing the long loops, recursion makes the programs easier. Example like this. Okay. So that's it for that session. In the next session, we'll continue with the seventh topic. Okay.